mute the mics and then we'll make a start this today. Okay, let's go. Yeah, thanks very much. Let's get Shrinet. Let's mute there. Okay, so welcome to the session where we're talking about getting started with Azure Infrastructure as code using Terraform. So one of the main reasons why I decided to do this is this is one of the areas that I've seen a lot of confusion. So when it comes to this, so um, just to give you like an explanation of what I mean by that. If I say to a lot of you, infrastructure as code, or a lot of people, not a lot of you, not necessarily you that are joining this session. If I say a lot of people, infrastructure as code, or if I say to a lot of people, DevOps, right? The things that comes to your mind will probably be things like Chef, Terraform, Ansible, Puppet, um, Git or GitHub, VSTS, Jenkins, and all this wide range of applications and technologies and vendors out there. So are the sort of things that comes to your mind, and Dockers and containers and Kubernetes and all this stuff. But sometimes it does not make sense to many people, especially if you're coming from the IT professional world, which this is not the way that you used to doing things before, and these sort of technologies are new to you. So what we're going to try to do in this session is we're going to try to unpick some of those and make them a bit clearer for us to understand. So first of all, I know if you already know who I am, but my name is David. I'm a cloud solution security architect, Microsoft certified, Microsoft trainer also. The thing that we'll try to cover today, we'll try to cover the things that we have on the screen, but actually, let me just go over to the next slide, and that's what we'll try to cover today. So first of all, we'll try by defining what DevOps is. And if you pay attention to this one, because this is not going to be a generic DevOps explanation that won't make sense to you. So I promise you, this will make sense to you at the end of this. So what we'll try to do is understand when people say DevOps, what exactly are they talking about? Then we'll move to the next stage will be infrastructure as code. How does infrastructure as code, how does it fit into this overall framework of what people call DevOps these days? Then after that, we'll take a step further and then we'll start talking about this particular tool called Terraform, which is a tool that's produced by a company called Ashikop. So they make other tools that fit into the old DevOps framework, like Packer and Vagrant and other tools like that. So we'll talk about that. So when we get to the introduction to Terraform section, then after that we'll start doing some practical stuff. Where we'll talk about Terraform and Azure, how you can start getting to use this, and this will be very, very simple and straightforward to you. I guarantee you that if you've ever used Azure Ham templates before, this will be really straightforward to you. It's just understanding how things work with this. And then finally, we'll talk about, or we'll do a demo of deploying our first Azure resource using Terraform. So that's essentially a brief agenda of what I'm looking to cover today. So let's start by talking about DevOps. So before I even start talking about DevOps, I think it's good that we spend a little bit of time understand what's the problem that we're trying to solve, right? What exactly are we trying to improve? Like we say, you go to your manager or to your organization, you say, let's start implementing DevOps principle. What's the problem that you're trying to solve by implementing these principles? What's gone wrong? What's going wrong with what you're currently doing? So for us to understand that, it's important that we understand the whole process or the entire process. That when it comes to software delivery, it's important to understand that. So what you see on your screen on this slide, it's a general overview. So this will be different for different organizations, but it's a generic overview of what many organizations go through to deliver software to the end users. So typically you have the developers who write the code and write the programs and develop the code. They check that into some form of source control system, Git. I'm sorry, put VSTS, but into Git or Microsoft Team Services. or whatever source control system that they use, which other one, Perforce, other source control system that exist out there. Git is by far the most popular still. So, and then that gets checked into whatever branch. The QA team starts to do a bunch of testing. They test the code. If it passes like all the tests that they've defined, then it gets checked into another branch where it goes over to the operations team, whose job and responsibility it is to take this code and deploy on infrastructure that's going to run the code so that the end users can actually begin to make use of the services that this was meant to deliver. So it goes through like all these different processes. And you say, why are we talking about this? The main reason why I want us to understand this is that it's important to know whenever we're talking about DevOps that when talking about software delivery and software delivery in an organization, software is not done when the code is written on the developer's computer. So that's not when it's done. Software is not done on the other stage when the testers have said, well, this code has passed our defined tests. That's not when software is done. Software is also not done when that gets passed over to the operations team, whose job it is the operations team to provision the infrastructure, to manage the infrastructure that's going to run the code, to ensure that the infrastructure is scalable, that it's available, that it is secure, very important into this world. So, but software is not done when it goes through all these different stages. Software is not done until it gets to the end user, right? So that's very clear from what we can see now, right? That's very clear that software is not done until it goes through all these different processes, and then the operations team has done all their work on it, and then it's ready to be used by the end user. That's when you can say software is done. As the reason why that is important is that if we're going to improve the overall process for software delivery to our end users, we can't just improve just one part or one component of this process. We have to improve everything. Because if we improve the developers in the way they write code and the way they check things in, and QA, we automate like their entire process of testing. If there is still a bottleneck at the operations section, where the operations team still has to go through a bunch of processes to manually click next to build an infrastructure, and then to connect this network to the other network, and then to make that available, and then to do the update. If the operations team still have to go through all these manual processes before the software can actually get to the end user, that's a bottleneck in your entire process. That's what DevOps is trying to address. What DevOps is trying to address is we have all these different teams, development team, operations team, testers, and all this stuff. We have all of them using different tools, right? And we're trying to merge together all these different teams and all the different tools that they're using, and even the processes that they're using to make the um, entire process of delivering software more efficient. That's what we're trying to solve here. That's what ultimately we're trying to get to. That's the goal that we're trying to get to. And I have, for example, a sample slide. If I go, let's go to slides forward. Let's go a couple of slides forward. Let me show you an example of that. So you say, what impact does that have? So if you look at this, for example, where an organization that has not gone through the process of implementing DevOps principles, which includes people, process, and practices in the organizations. Probably doing something like 2 releases a year to their software. So you did the first release and then you do the second release. But when you get to a place where you've automated everything along the whole chain of software delivery, including the operations process of provisioning infrastructure and managing the infrastructure and securing the infrastructure, you can actually get to the point where your releases are much more quicker to get out to the end users because you're used to doing this. It's all automated. If something fails, you can fail quickly and fail back very quickly also because it's all automated. There's no manual step in the entire process. You're not afraid of changes. And so you can do much more releases. And we'll get to that again when we get to the benefits. But I hope that that at least gives us a bit of framework as to what we're trying to solve here. So when we talk about this whole thing of DevOps, um, the other thing that we should know also is that we're not talking about tools. So there's nothing like DevOps software or DevOps application or a DevOps team. That's not DevOps. You get a bunch of people together, you call them, these are DevOps team. That's not DevOps. DevOps is a whole combination of team, which is people, of processes, and some of the processes. So on the screen, what you're seeing in front of you, the principles of DevOps, you can see that it includes tools, it includes processes, it includes practices, it includes culture. So you see, number one, here you see a cohesive team. So where developers and operations are working together as a cohesive team. They are using a similar process that the development team use to check coding, to run tests against the code, is the similar process that the operations team are using to check coding for the infrastructure, to provision their infrastructure. It's the same process. So they understand each other's languages more because they're using the same process. And because of that, there are other practices like modular architecture, which is the development side of things. If you make things um, neatly coupled, it becomes much more difficult to release changes to them. So then we have things like continuous delivery, which is a set of processes, continuous integration, a set of processes. We have things like strong source control, which is a tool, let's say Git or whatever source control that you're using. So there's tools involved in DevOps, there's processes involved in DevOps, there's people involved in DevOps. Okay, and generally speaking, when you talk about like the core values of DevOps, they're like four main ones that people talk about. Again, this is all subjective depending on which textbook you're reading or which website you're looking at or who is doing the presentation. But these are the four general ones. We talk about the culture has to change in terms of approach to change. Automation has to be built in from all the way from the beginning all the way to the end. Actually, that's what we're focusing on today. We're focusing on the automation aspect because for us that we work in the operations team, that's the area that we typically get started with this whole process. It's let's automate all our processes. All the things that we've been doing manually so far, let's get to the point where we automate all of this. And then things like if you're doing that, then you have to have a way of getting feedback really quickly, which means you have to have robust monitoring and you're measuring things and you can detect failures that you're testing, processes can detect, and then sharing. So you may be thinking, okay, yeah, I get it. I can see like what we're trying to solve now. Is there like any real numbers in terms of the benefits of this? Here are some of the numbers that you find out there. Actually, there's a very nice article that I'll probably put in the description of the video that um, talks about the companies that are doing DevOps very well and the benefits that they've seen. So, for example, you take Nordstrom, for example. After implementing the principles of DevOps, and remember the principles, we're not just talking about tools, we're talking about tools, we're talking about the processes are changing, the teams or the people, and then we're talking about practices, and then tools is part of that also. So Nordstrom, for example, they're able to double the number of features that they deliver per month just by adopting the principle where it's much more easier for them to deploy infrastructure, to deploy their code. As they deploy the code, they can deploy the infrastructure all automated. So they were able to double the number of features they delivered in a month. They were able to reduce the defects by 50%. Because rather than spending time as IT operations people clicking next, 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 and try to troubleshoot manually all this stuff, you really don't spend a bunch of time like trying to break things that are trying to fix things that are broken. You spend your time adding value to the organization rather than trying to um, break things that are or trying to fix things that are broken. Reduce lead times, for example, by 60%. Reduce the number of production incidents by 60 to 90%. So when they deploy things, because they are so used to the process of continually deploying things, right? So they were able to stabilize their infrastructure, the environment to the point that they reduce the number of incidents that happen after they do a deployment um, by 60% to 90%. So another example there is HP LaserJet's firmware division, where the amount of time that is spent on developing new features went from 5% all the way to 40%. The overall development costs reduced by 40%. So that's some of the benefits that organizations that have adopted this framework are seeing. And this is the slide that I showed to you earlier where you can see. So instead of you, because deployment is so difficult, provisioning infrastructure is so difficult, changing them is so difficult, then we have to get all those changes together as big changes and then deploy them like only a few times. And imagine you have your customer waiting for the changes that will change or that will benefit their organization. Your developers have worked on it since January, but because the operations team are still doing things in a very old way, that um, new feature that development team came up with cannot get to the customer all the way until June because we can't touch the infrastructure. Things cannot change. Everything has to be done manually. We have to click through, we have to click that. And because you're not used to the process of continually changing and continually just making changes to code to update your infrastructure. If things fail, it's very easy to roll back and fail quickly. Okay, so moving on, for example. So now let's move to one of the building blocks of DevOps. So now that we understand like the whole framework of what DevOps is meant to solve, one of the core building blocks of DevOps, especially when it comes to us operations people, is infrastructure as code. This is one of the building blocks that we have to pay attention to. And let's look at some of this. So this is where it begins to get confusing. Because the moment you talk about infrastructure as code again, instantly in your mind, you're thinking Puppet, Chef, Ansible, Terraform, um, Gate. You're thinking about all these vendors, and it does not make sense what this one does that this one does not do, where this one fits into that. So that's what we'll try to unpick here. So one of the first things that we have to understand when it comes to infrastructure as code is that there are four main categories that infrastructure as code involves. Four main categories. So number one is configuration management, which we'll talk about in a minute. Then server templating, then infrastructure provisioning and orchestration, and then ad hoc scripts. So we'll talk about all these four categories quickly before we go into the first demo for today. I won't touch on ad hoc scripts. You see the reason why I won't touch on that because it's missing some of the core um, component or principles or best practice principles for infrastructure as code. So I won't really spend a lot of time because actually this is not where you really want to be, except there's no other solution for you than to do this ad hoc script. So you essentially want to be implementing a minimum of at least two of these, where you're implementing infrastructure provisioning with server templating or infrastructure provisioning with configuration management. So let's move on quickly. So what about configuration management? So configuration management, we're talking about um, tools that are designed to install and manage softwares on existing servers. So let's pay attention to this. So configuration management, it's not meant to provision infrastructure. It's meant to manage the configuration on existing infrastructure. So that's very important. So this is an aspect of a category of infrastructure as code. Not the only category, but a category of that. It's not meant to deploy infrastructure. The main role of configuration management is to manage infrastructure that we've already deployed by some other means. So some of the tools that you hear about when you're talking about configuration management, you hear about tools like Ansible, you hear about tools like Chef, you hear about tools like Puppet, you hear about tools like SaltStack. So all these tools that I've mentioned, they fall under roughly under the category of configuration management tools. Their main purpose or main aim is not to deploy infrastructure, but to manage configuration, in other words, install software on existing infrastructure. Now, there are areas where they cross that boundary. For example, you can use Ansible to provision servers on Azure. But it's sort of like, is that the best way to do things? You have to think about that. So even though they may cross certain boundaries in terms of the main thing that they're designed to do, you have to think about, is that the right solution for you or not? So just be aware of that. So here's an example of, for example, an Ansible template that provisions Apache on existing Linux servers. So you're just specifying provision Apache web server on existing servers. So let's move on to the next one. So the next one is where we talk about templating. So templating is another category of infrastructure as code. Now, templating is an alternative to configuration management. Configuration management, we're taking existing infrastructure and managing configuration on them. Templating does the same thing, but in a different way. What templating does is, rather than managing configuration on existing infrastructure, what template does is before you build the infrastructure, I'll manage the configuration on the image. So under templating, we're talking about images. And under images, we're talking about two main types of images. We're talking about either virtual machines or containers. So take, for example, this code on the left here. What this code would do is this code, it's not the full code itself. Actually, let's bring up this and let's go Azure Packer image. Let's bring this up and then let's go here. So look at this, how to create Windows Azure Virtual Machine images with Packer. Let's expand that so that you can see the screen here. So for example, you see this tool called Packer that you can use to build images for Azure. And then you see an example of what that works. So what you can do is you can use code to define what an image looks like. And then once you've defined it, you can use Packer to build that image and then deploy that image to Azure. So what that will look like would be you define and say, in this case, let's say you say I want a Linux server, but I want on the Linux server, I want it to have Apache installed. I want it to have MariaDB installed on that. You define all of that as code or as a template. You give that template over to Packer. Packer is going to build a VM image based on that template, and then you can now deploy that image to Azure. So this is a different way of achieving the same thing that we can achieve with Ansible. But what Ansible does is the infrastructure has to exist first of all, then I can make changes to it. This one before the infrastructure even exists or before you even start deploying the images, you're making changes to the images using code. So here we're talking about tools like Packer when we're talking about virtual machine images. And when we're talking about containers, we're talking about Docker. Does somebody have a question? I can see somebody's unmuted at the moment. Actually, I can probably pause a bit here. Let's see if anybody has a question before I move on. Any questions so far? So far we've talked about server templating and we've talked about configuration management aspect of infrastructure as code. Any questions? Good. Okay. Nice one. Good. That's nice. Let's move on then. We have infrastructure as code, so server templating. So just be aware of those other categories. So it's essentially they do a similar thing but using different methods. The only main difference when it comes to yeah, carry on. Yeah. Not ARM template. So this is so what you're seeing to the left here is not ARM template. This is it, no. So ARM template, you'll see the category that ARM template comes after. So that's what we're talking about. So that will be the number three option. So which is infrastructure provisioning. Okay, go ahead. Oh, we'll get there. So that's the next one. So we'll get so you're essentially both of you are asking the same question, which is where does that come in? But the main thing that I want us to understand is so that it won't get confusing to us later is to understand this, the different categories. Configuration management, be a separate set of tools that deals with, as long as I have an existing infrastructure, I can modify the configuration on them. Server template is I can define a code, hand it over to a tool like Dockerfile, or hand it over to a tool like Packer. It's going to build an image, and then you can deploy that image to your environment. So server templating works in line with something called okay, yeah, carry on. Exactly. So thanks for bringing. So that was what I was about to say that server templating essentially when you're talking about this, you're talking about what people call immutable infrastructure. And for those that don't understand what that means is once you define your image. So for example, you define version one of your image and say this version one has Apache version two installed. And then once you provision that, you do not make changes to that image in production. If we mute ourselves if we're not asking questions so as not to impact the recording. So can I answer this question quickly and then we'll get to the question? Yeah. Oh, yeah. No problems. So the immutable infrastructure. So where once you deploy your infrastructure, your environment, or your images, you don't make changes to those images in production. So what that will look like, so because let's bring up Paint here. What that will look like is I define using Packer code or Packer template, and I say I want Linux machine, and I want my Linux machine to have Apache 2 installed. So I take this code, I hand it over to Packer. Packer is going to build an image on that, and I have my image. I can deploy that image to Azure as a custom image in Azure. Now, once I deploy this image to Azure, I don't make any changes to this image. If I want to make any changes, I go back to my code. So let's say Apache releases Apache 3 now or whatever, right? You don't go and start deploying Apache 3 on this production image. What you do rather is you go to your code and modify it to have Apache 3, and then you hand it over to Packer to build a new image based on that, and then you replace the existing image with this new image. In other words, you don't make changes once you've defined this and that's in production. Rather, what you do is you use the process of you destroy this image and or you bring up the new image and then destroy the old one. Does that make sense to us, right? So that's the opposite. So that's what they call immutable infrastructure. In other words, you don't really make changes once in the production. You leave them once it's in production. If you want to make changes, you make changes to the code, build new images, and then you carry on with that. Does that answer your question? And the person that asked the question, sorry. You can unmute yourself. Yeah, yeah. Can we have what? Sorry, I didn't catch that. So here's the thing. If you think about it, so why would you want VM extensions? Because this is image, right? Yeah. So this is not. Yeah, yeah, yeah. No, you deploy it, you specify it. So the way that this works is you have. So let's go here back again. So for example, you look at this. Let's go. Let's go sample Packer Apache. Let's get some real code. Okay, this one will give us an example for this one will make it a bit clearer, hopefully. Um, Packer for example the JSON. Let's see. I can't see. Okay, let's go. It's okay. Here we go. So here's the JSON file. Let's open that file and let's see an example of this code. So if you look at this, this is not this is not AWS. This is a Packer template, for example, right? This is what you're defining as an administrator. You're defining this and you're saying, build this. I want you to build an image based on this. Use this source AMI. This is the instance type version. Also, you can specify what software you want to put within this using whatever syntax the Packer supports. So once you've defined that here, you hand that over to Packer and Packer will build an image based on what you've defined here, right? So if you want to make changes, what you do is you make changes here in this code and hand it over to Packer and a new image will be built based on that. Does that make sense? Yeah, okay, good. So okay. OJ, what was your question? Sorry. Yeah, yeah. Yeah, yes. So the way it fits together is we have DevOps, which is essentially it's not the main, but the main thing we're trying to do with DevOps is to have a more efficient more efficient process of delivering software in an organization. Um, so I'll answer your question, Jada, in a minute. So it's to improve the way the processes of delivering software in an organization. Now, to be able to achieve that, you have to make improvement to your people, you have to make improvements to your processes and your practices and also to the tools that you're using. So one of the main building blocks of DevOps is infrastructure as code. It's not the only building block. So if you just implement infrastructure as code, that does not mean you have DevOps, right? It means you've implemented one of the main principles of DevOps, right? So then there are other principles that you have to improve on. So your development teams becomes more agile, your processes becomes more streamlined. There are other principles that we talked about in the earlier slides that you have to implement, and then a combination of all these improvement in people, processes, your tools and your practices, everything comes together, and then you have DevOps. Yeah, yeah. So it could still be the same roles or whatever you may call it, but the only thing that will change is the way that your activity changes. So you're not spending your activity rather than spending your activity troubleshooting things that are broken, trying to fix them. You're spending your time improving your infrastructure code, making it better. So for example, you're like, okay, if we deploy our infrastructure using this current version of the code that we have, everything can be deployed within 15 minutes. Okay, what improvement can we make to make this better? To bring it down to 5 minutes. So you're spending your time on things like that rather than spending your time on, oh, this is broken. Let's log into it and let's click next, next, next to fix that. Yeah, no problems. And Jide said, is there a cost to using Packer? So Packer is open source. To be able to support it, there could be a cost if you want a supported version. So to be able to get support for it, there could be a cost to it. But Packer itself, it's all open source. So similar to Terraform. So Terraform, which we'll talk about in a minute, Terraform is open source, but there's an enterprise version of Terraform. And if you want to use that enterprise version, I think that there may be a cost to that. It's not something that I'm really too sure, so don't don't quote me 100% on that. I'm not sure if there's a cost to Terraform Enterprise, but I'll assume that there should be a cost to it. But it's currently open source, so you can. Okay, okay, let's move on then. So we've talked about configuration management, server templating. So all this fall under the category of infrastructure as code, so that now you understand when we are separating things, where things lie. So then there's another category which is for provisioning and orchestration. So here we're talking about tools, which you'll now begin to understand. We're talking about tools like the Azure Ham template. We're talking about tools like CloudFormation. We're talking about tools like Terraform when we're talking about provisioning and orchestration. The job or the role of the tools under this category are mainly to provision infrastructure or to provision resources. Remember that the job or the role of these tools is not to configure existing servers. It's not to build images like Packer does. The role is to provision infrastructure on different platforms or on platforms. So Azure Ham template, for example, um, what's the name? Azure Ham template, CloudFormation template, and Terraform. So Terraform falls in the same category as CloudFormation and Azure Ham template. They are for provisioning infrastructure. So that's where they fall under. So configuration management tools, server templating tools, they define the code that runs on the servers. Terraform, Azure Ham, CloudFormation, OpenStack it. They're responsible for creating the servers themselves. So how do we create the environment? But it goes beyond servers. We're talking about creating storage account, S3 bucket if it's AWS, Azure App Service, Azure SQL, whatever infrastructure you need to deploy, you're deploying using a form of code, using either Ham templates, Terraform, or if AWS CloudFormation. So that's what this falls under. So now that we understand like these three categories, let's move on and talk about some of this because this is what will lead us to answer the question that some of you have asked. So if Terraform does the same thing that Azure Ham template does, what are we trying to do here? Why, why are we trying to make our lives complicated by adding another tool? So we'll answer that question in a minute. But before we answer that question, it's important that we understand some of these best practice principles for infrastructure as code. And I need to add a disclaimer here because these are not like industry-wide, you know, best practice principles. It's just David, David, what I've learned from different sources that best practices when you're talking about infrastructure as code. So number one thing is infrastructure as code has to be able to automate your infrastructure provisioning and your server configuration. In other words, you have to be able to automate the deployment of your resources, of your infrastructure, and also the configuration of your infrastructure afterwards. So either the tools that you're using can do that, or they can link in together with one another. So I'll give you an example of that. Azure Ham template, for example, can automate the provisioning of your infrastructure, but it cannot sorry, not bot, sorry. It can automate the provision of infrastructure, but when it comes to configuring the infrastructure, Azure Ham template hands over to another tool to do that. That other tool could be custom script extension, like we know in Azure. It could be Chef, it could be Puppet, it could be Ansible, but it has integration with configuration management tools to do the configuration, but it is going to do the provisioning. But it's going to be able to automate everything from the beginning to the end. So then this other one about idempotence is also important when it comes to best practice in terms of the tools or when you're talking about infrastructure as code. Idempotence is when you deploy an infrastructure and then you have to make changes. How do those changes happen? So I'll give you an illustration. If I write a PowerShell script and I say new Azure virtual machine, Azure RM VM, provision, whatever, enter, I've deployed that. If I need to make changes to that, and I go to my PowerShell script and I make one change and I run the whole script again, I'll probably get what we call in IT the wall of blood, right? It's a bunch of red and it's going to say, hold on, what you're trying to provision already exists. Now, that is not good. Now, that is not great. The reason why that is not great is you can't use that to make changes to your environment, whereas other tools like Azure Ham Template or CloudFormation can be intelligent enough to know, okay, you've just made a change to this part of the code. Therefore, what I'll do is I'll go ahead and deploy just or modify the existing ones or deploy new changes that you've made, but I will leave the existing ones untouched and I won't throw an error message. So that's idempotence. Idempotence is being able to realize the current state of an environment, what has changed, and knowing these are the only things I need to change. I don't need to be throwing error messages if something already exists because I can detect that for myself. Then there's also the declarative versus imperative. So declarative is much more better than imperative. When we're talking about declarative, you already know this from Azure Ham versus PowerShell. PowerShell, you have to go new, Azure Ham storage account, wherever you type in your PowerShell commandlets to do the job, right? So here's the issue with that. Microsoft could come in the next 3 months and say, apologies, we're retiring this bunch of PowerShell commandlets, and we have a new bunch of PowerShell commandlets that will be replacing that. What that means is now you have to go through your code and you have to go modify your entire code to fit into that. To go, okay, let's change this entire PowerShell commandlet to this new one and all that stuff. And also you have to specify everything line by line by line, right? Which is not great. So declarative is where you essentially, so let me show you an example of that. So if I just go, because we're talking about Terraform and Azure today, let me bring up um, Terraform Azure, and I'll bring up a documentation. Okay, use Terraform to create a complete Linux VM. So we'll explain this later. Don't worry. I just want to use this to bring a point. So look at this, for example. I want to define a new Azure virtual network. I just specify the name of the virtual network, the address space of the virtual network, the location, and the resource group name, and whatever tags. That's it. I'm just declaring what I want. I don't need to go specify the commandlet to use to do this. What this means is if Microsoft were to change the PowerShell commandlet that they're using in the backend for creating virtual network, that does not concern me, right? Because Terraform will make that change in the backend and that will apply to my template. Now I don't need to be worried about now I need to go run around, modify all my templates to do this. I'm just declaring what I want. Whatever method that Terraform needs to use to achieve that, it's up to Terraform to do that. It's the same thing with Azure Template, but that's the best practice of infrastructure as code. It's declarative is better than imperative. So we'll talk about this also, platform agnosticism. Agnosticism. I think somebody's unmuted. Don't worry, we'll have time for questions very soon. I know. I promise you. So let's go mute. Oh, who's unmuted? Somebody's unmuted. Okay, yeah, that's better. Okay, so let's move on quickly. So platform agnosticism is another good principle of infrastructure as code. So some of you may already have known like one of the disadvantages of using Azure template, for example, versus using something like Terraform. Because one of the issues, not the only issue, but one of the issues that you have with that is, what happens if your infrastructure extends beyond Azure? How do you deal with that? What if you're using a multi-cloud strategy where you're using both AWS and Azure? Now you've got to work with CloudFormation templates. You have to work with Azure Ham templates. What happens if you're using Google Cloud also? So now you have to work with Azure template, Google Cloud provisioning tool, and then CloudFormation template. What happens if your DNS provider is using something like DNS simple website for your DNS public DNS registrar? What do you do? Then they have a different tool that you have to use. Okay, on-prem also you're using VMware vSphere and you want to improve all your processes to infrastructure as code. Now you've got to go use whatever tool that VMware has. Now you've ended up with more confusion because now you have a bunch of tools for all these different providers that you're dealing with. And complexity is not a very good thing, excuse me, when it comes to this area. So robust integration with other tools. What do we mean by that? What we mean by that is if whatever tool that you're using to provision your infrastructure, if it cannot configure your infrastructure, it has to have integration with tools that can configure your infrastructure. So Azure does that very well with the Azure template. It can provision, excuse me, it can provision your infrastructure, but it can't configure it. So it's going to hand over, and it has integration with Chef, has integration with Ansible, has integration with Puppet, has integration with custom script extension. Same thing with Terraform, has integration with all these other tools to go. I can provision your infrastructure very well. I'm not good at configuring your servers once they've been provisioned. Chef is better at that, but I can integrate with Chef to hand over to Chef to configure after I've deployed. So that's very important, right? Because you may find that very difficult to do if you're thinking, why don't I just use PowerShell for everything? Well, how do you integrate with configuration management afterwards? And then ease of extension, because there are certain situations where you want to provision certain services that may not yet be available in the tool that you're using. So they must have abilities for you to be able to extend to cover other areas that they may not cover natively. So those are just a bunch of best practices that I've just listed. And what we'll try to do here is we'll try to look at the native infrastructure provisioning options in Azure that we have, and then compare them against these principles. Take, for example, Azure Portal. Azure Portal fails principle number one of automation, right? How do you automate the portal, right? So that fails that principle. So that's out of the picture. Azure PowerShell. Well, that's fine because we can use Azure PowerShell. We can do automation. That's fine. But what about idempotence? We already explained earlier we can't. Because if you try to make a bit of change to your code and redeploy, you get a bunch of errors. Same thing with Azure CLI. You get a bunch of errors saying this already exists, this already exists. They don't have the intelligence. The intelligence is not built into them to realize the existing state of the infrastructure and realize this already exists. I just need to modify this, this, and this that you've modified in your code. So essentially, they fail option number two, both Azure PowerShell and Azure CLI. And they fail the declarative option, and definitely they fail platform agnosticism, right? So let's move on. What about Azure Ham template? Yeah, Azure Ham template passes automation. It does idempotence. It's declarative, but platform agnosticism, it fails that because you can only use it with Azure. What happens if you're doing AWS? What happens if you're using Google Cloud? What happens if you're using VMware vSphere on-prem? What happens if you're using a different CDN that's not Azure based? It's not every infrastructure that you just do everything in Azure, right? You may have your CDN provider that's giving you a very good deal outside of Azure, and you're using that CDN provider, but also you want to bring all your provisioning into this single tool to do everything, right? So Azure Ham template fills that. So for the people that ask the question about what's the difference between Azure Ham template and Terraform, does that answer your question? You can unmute yourself. Yeah, was it Hanil that asked the question about that? Did that answer your question? Yeah, are you good? We can move on. Yeah, everybody good? Okay. Any questions so far before I move on again? I don't want to take too long. I want to get to the demo very quickly. Are we all good? Okay. So moving on, let's talk a bit about Terraform. I skipped one of the slides because I don't want us to spend time talking too much. So first thing to mention is what Terraform is not. So we've talked about some of this, so I'll move to them very quickly. Number one thing to understand is that Terraform is not a configuration management tool like Chef and Puppet and Ansible and SaltStack. That's not what it does. Terraform is not a server templating tool like um, like Packer or Dockerfile. That's not what it does. It's not a cloud abstraction layer. It's not a layer that you can layer on top of Azure and then make REST API calls to Terraform. That's not what it does. So if that's not what Terraform does, what exactly is Terraform then? So Terraform is a tool that was developed by a company called HashiCorp. And what Terraform, sorry, excuse me, got some distractions. Got onto here. Okay, much better now. Okay, so yeah, so Terraform is an open source tool that was developed by a company called HashiCorp, and it's a tool that was written in the Go programming language. It's essentially a tool that you can use to automatically provision resources across multiple providers using a single tool. That's one of the main advantages of Terraform. If you don't have to use a different tool, if you're using multi-cloud strategy, you can have a single tool and provision your infrastructure across multiple providers. And you see how large that range of providers that we can use Terraform to provision infrastructure on, how large that whole range is. So Terraform itself, it's just a binary that you download and you install on your machine. So you essentially just download the binary, install it on your machine, and Terraform essentially is deployed on your machine. So the other thing that we need to understand about Terraform is that it can work on Windows, it can work on Linux, it can work on Mac. It's supported on different variants of Linux. Because under the hood, what Terraform is essentially doing is once you've installed this application and you give your Terraform templates to the Terraform application, it's going to convert the template into API calls. If you've specified to provision infrastructure on AWS, it's going to convert that template, that declarative template, into API calls and make API calls to AWS, API calls to Azure, API calls to Google Cloud, API calls to DNS provider, API calls to CDN provider. That's what it's going to be doing in the backend, but it's a very, very simple tool to use. So in the backend, it's just making REST API calls on those. So let's do our first quick demo here quickly. Terraform installation. So we'll probably start with, let's go to, I think I have a Windows virtual machine over here. Running server 2016, but it can be any Windows machine that you have. So let's switch that off first of all. And what I need to do is I need to let's go hide. Oh, here we go. Because I need was hiding the other stuff from me. Let's go. So what I'll do is, oh, did I just close that? Let's go to Terraform. Let's search for Terraform. Whatever search engine that you like using, just search for Terraform and you'll be good. What I need to do if I maximize this so it becomes easier for you to see. There we go. If I go to terraform.io website, I can just go under the download section directly. And under the download section, I can say I can download the Mac OS binary, FreeBSD, different Linux variants, OpenBSD, Solaris. I can download the Windows version. If I download the 64-bit Windows version, I can save that. So one of the things that you probably notice once I download this, if I go under my downloads directory, and then if I unzip that, extract it, one of the things that you see with this is that it's not really an application that you install. So for example, if I try to double click on this to say install it, you'll see what will happen. So it's not an application to install. So it's like, yeah, what happened? Because this is not an application that you install. It's a binary that you run. So what I need to do is I need to copy this, unzipped application file. What I'll do is I'll go under my C drive. I just like doing this. You don't need to do this. You can put it under whatever directory that you want. I'll create a new directory called Terraform under my C drive, and I'll just put this executable under this directory, and that's it. Now, if I go under this, I can start using Terraform. It's as simple as that. So it's not something you install, it's just something you download and unzip. It's the same way on Linux, it's the same way on Mac. Let's maximize this a bit. Let's go properties, and let's make the font larger. Let's make it 36. That'll do. Yeah, here we go. If I go change the directory to C Terraform, then if I run Terraform, you can see. So that is how I begin to use this. If I want to make it much easier, so I don't need to change that directory, I can add C Terraform to my environment path, so that whenever I load command prompt, it's going to load anything that's under this environment path. So I can do that. So that's one of the ways to use this. And instantly, that's all. I can begin to use Terraform on this machine. If I do Terraform help, I can begin to see how the command apply. I can begin to make use of this. Now we get to how to make use of this in a minute, but that's it. That's done. But this is not the only way to install Terraform on Windows. This is a manual way to install it. Now I've installed it, but I also need to add this part into my environment variable. There's a better way that you can do. So if you're familiar with Chocolatey, which is an automated way of applying applications on Windows using PowerShell, you can essentially use Chocolatey to install Terraform also. So if I change this to PowerShell, and if I just, number one, I need to have Chocolatey on my machine. So if I run that, that will get the latest version of Chocolatey. So it's a packager, it's a Windows packager, similar to like the way, if you're familiar with Linux, like Ubuntu, the way Yum or apt-get will work. So now I have Chocolatey running on this machine. Now if I do something like choco search Terraform, and I run that, it's going to run a search and it's going to go, listen, I found Terraform 0.11.7, which is the latest version. Because if you go under here on the Windows, if you look at that, that's 11.7, which is the latest version. So I can use Chocolatey to install it, which I just do choco install Terraform. Now, if I do this, I don't need to go set up the environment path variable afterward. Chocolatey will handle all of that for me. It's going to download latest version of Terraform. It's going to set it up in my environment path so I can carry on using that. So that's the way to install it on Windows if you're going to be using Windows for your Terraform machine. So let's move on. What about Linux? I've got a Linux machine here, and Linux is what I'll mainly be using today. So if I restart my session, ensure that I'm logged in. What I'll do is again, I'll make the screen much bigger, so to make it much easier for you to see. So I'll change that to 24. That should do. Yeah, that'll do. And what I'll do, let's clear the screen. So I've got an Ubuntu 17.10 Linux machine here. So to install Terraform on Ubuntu, first thing I need to do is I need to get the URL for I need to get the URL for Terraform for Linux that I want. So if I go under the download site for Terraform, I have Linux 64-bit here. If I right click, I can copy where is that? Properties, and then I should be able to copy the URL from here. And then once I have this URL, essentially what I'm trying to do on Linux is do the same thing I've done on Windows, which is to download the zip file and unpack that zip file into a directory, and then I can begin to use it. So I'm just trying to do that using Linux. So before I do that though, I need to have, because if I check unzip, which is the unzip tool that I need for Linux, I need to have unzip installed on the machine because that is the tool that I'll use to unzip the package once I download it. So I don't have it installed, so I'll first of all run that command to install unzip on my machine. And once I have unzip on my machine, then I'll run the command to download the zip package for the zipped Terraform package, and then I'll unzip it. So let's go. So yeah, that's done. So now I have unzip on my machine. Now let's use call. So I'll use that. Let's go. Let's go this, and I'll just paste this here. So what I'm doing is using call, and I'm saying go download this URL that I got from the website. So if I run that, and that's it. If I do a list, it's already downloaded that zip package here for Linux. And then what I just need to do is run unzip to, if I run unzip, that will unzip that package to user local bin directory on Linux. So if I run that, okay, I need sudo. So if I do sudo, and that's done. So if I do my list user local bin, and now I have Terraform installed. And now because it's in the bin directory, if I do Terraform-3, I can see Terraform now installed on my Linux machine. The other one that I want to show you is actually one that it was an interesting one for me to find out when somebody from Microsoft announced this. I was like, wow, that's interesting. So it's, let's go to, I need to log into my Azure environment first of all. Forgive me for not logging in already. Log into my Azure environment. Essentially, Terraform is pre-built into the Azure Cloud Shell. For one at Outlook, let's log into my Azure portal. And within my Azure portal, once I'm signed in, if I go to shell.azure.com, which will take me to the Azure Cloud Shell, and so I'll change the font to something larger so that you can see that. And then you notice that Terraform is already pre-built into this. But if you're going to be doing something, you're following a much more robust process of you're integrating it with Git, you probably won't be using the Cloud Shell. You probably will be, you can use the Cloud Shell to practice is what I'm saying, but if you're going to be doing something in an organization that's much more robust and following much more well-defined process, you'll probably be doing this on your provisioning server, the server that you have for provisioning infrastructure in your environment, or from an admin's workstation. If I do Terraform-V from the Azure Cloud Shell, you'll notice that it may take a while, but it's going to come up and tell me the version. So now we have the latest version of Terraform that's running in the Azure Cloud Shell. We don't have to do anything to begin to use that. So now that we have Terraform installed, let's run through the rest of the slide and then let's do a bit more demo into how we're actually going to start using Terraform. So how do we even begin, like when we talk about using Terraform to provision infrastructure? Now, we mentioned earlier, that under the hood, all that Terraform is doing is that it's making API calls to different resource providers to provision infrastructure. And one of the advantages that it has is it has multiple providers that are supported. But here's the question. How does Terraform know which provider to make the API call to? How does Terraform know how to authenticate against that provider? So the answer is very simple. The answer is we have to tell Terraform the provider that we want you to provision these resources on, and then we'll have to tell Terraform how you're going to authenticate against that provider. So we have to do that with Terraform. So Terraform itself using the template that has a .tf extension, and that's very, very straightforward. All you need to do is create a file inside the directory that you're going to be using and just call it .tf at the end. So that's all you need to do. The template itself, which we'll see in a minute, you can define it using something called HashiCorp configuration language, which is essentially a modified, to me, basically, it's a modified version of JSON. So if you're familiar with Azure JSON or with AWS CloudFormation JSON or YAML, anyone, you'll be cool with this. It's essentially similar. The only main difference is that they've made improvements with the limitations that we have in JSON. So for example, one of the main limitations in JSON is that you cannot comment. I think there's somebody's mic that's unmuted, so I may need to unmute that. Let's go for screen. Yep, okay. Here we go. So the main thing is that JSON does not have a commenting method. So there's no way for us to add comments to a JSON file, which can become difficult if you're using an Azure Ham template that's really, really long, and then you're not sure where something starts, where something ends. It can be really annoying. Same thing with AWS CloudFormation if you're using JSON. But what they've done is this HashiCorp configuration language has commenting included in it to hit, and that we can use. So the Terraform templates, we said we're going to tell it the provider that is going to provision our resources on, and we're going to tell it how to authenticate to that provider so that it can make API calls. There are two main sections in a Terraform template. Those are not the two only sections, just to keep it simple. There are two main sections. Number one section is the provider configuration. That is where we define the provider, like we want you to use Azure, we want you to use AWS, we want you to use Google Cloud, we want you to use Oracle Cloud, we want you to use VM or vSphere, and this is the authentication that you're going to use to authenticate to Azure, to VMware, to Google Cloud, whatever. So that's the provider section that we are configured at. And then after that, we have the resources section. The resources section are like, now that you've authenticated, now after you authenticate to Azure, here are the resources that I want you to provision. I want you to understand that I'm just trying to keep this basic. I don't want to go in depth to avoid confusion. There's much more layers that you can add to a Terraform template, but let's just keep it simple for now. This is meant to be an introduction type webinar, so we don't want to go in depth yet. Maybe we could have other different sessions later to go much more advanced. So let's just go to the next one. So here's one of the advantages to Terraform that you see here, providers. Now look at the amount of providers that you support. You have Amazon Web Services, Azure, Google Cloud, VMware, vSphere. Not only that, because once you provision your infrastructure, you may want to provision monitoring for your infrastructure. So it can also provision logic monitor. What about if you need public DNS to be pointed to the infrastructure that you just provisioned? It can reach out to DNS made easy. If you need something like CDN, it can reach out to Fastly, CDN. So it cuts across. What about if you're using an on-prem environment? It can use VMware, vSphere, OpenStack, Alibaba Cloud, Datadog, which is another monitoring tool. So you can see that it has a lot of providers, but this is not all the providers. Let's actually go to Terraform's website and see the number of providers that are supported. The last that I counted, there's like about 73 providers. Look at that. Look at the providers that you can use Terraform to provision resources on. Ali Cloud, look at that. That's a lot of providers. New Relic there. SQL, Oracle Public Cloud, Palo Alto, VMware, vCloud Vector, Ultra DNS. So you have multiple providers and it keeps increasing. And here's the other thing is if you're using some form of provider that's not yet supported, if you are exposed to programming or you're good at programming, you can actually write your own extension for the provider. and make that available. So some of you can go, if you go to Terraform community, you find provider support that community members have come up with. So it's extensible that way. And then you can use this. Essentially, this can be your infrastructure as code provisioning level. So remember that it does not do configuration management, but it also integrates with configuration management. It can integrate with Chef. Actually, let me show you that. It's not part of what I wanted to cover today, but if I go under provisioners, for example, you can integrate with Chef, with just connection using SSH or WinRM or whatever, with Salt, with remote execution, with local execution, with Habitat. It has integration with all these different provisioners that you can hand over to configure the infrastructure once they're done. So you can see provisionals can be used to bootstrap a resource, clean up, or run configuration management. So it can integrate with all of this. So it's a really robust tool, is what we're saying here. So how do we tell Terraform in our template what provider to use? It's simple. In the provider section, just define this. Provider, in this case, Azure HRM, and then define the credentials to authenticate to that provider. Same thing with any other provider. It can be provider AWS, authentication, provider logic monitor, authentication. I think the next thing is a, yeah, carry on, sorry. No problem. Yep, yep, yes, yeah, yeah. Y- yes, they are. They are. It's beyond the scope of what we're going to talk about here, but yes, they are. So one of the ways that you can do with that is you can make it a variable. So Terraform templates, I told you that it can be very robust, so it supports something called environment variables. Hmm. Yep. Yes. Yep. Not pivot. Yeah. So not pivot yet. User service principal. No, so I'll answer your question, Jide. So it's not that. So here's the thing for you. So in your own case, if you want much more robust features like what you're talking about, you may need to go have a look at this other form of Terraform called Terraform Enterprise. So you may need to go have a look at this one, which is Terraform Enterprise. Which I think may provide some of the things that you're referring to if you want a really high level of security with that. Um, so you should check this one out. Check out Enterprise and what it can do. Yeah, yeah. So, but in that way, so one of the ways that yeah, carry on. Sorry. Oh, yeah. So here's the thing. So that's really beyond the scope of this, of what we're trying to achieve in this particular webinar. So the main thing, I know that with many people, so it's very good that you've experienced in this. I know that many people, this is sort of like a new thing to them. It's not something that many people are really familiar with in terms of Terraform and that. So what I can do is at some point we can have a follow-up webinar where we talk about much more advanced topics of Terraform like modules. So modules is a really, really advanced topic in Terraform. So if I start discussing modules now, it may confuse people very quickly. I'm sure that you're aware. Yeah. So, so we've got to take it a bit slowly and then we'll get to modules eventually. But yeah, in order not to again spend too much time, we'll probably put that in a different webinar sometime. So just look out. What I'll probably do is at some point I'll probably announce and say, yeah, there's a bunch of webinars I'm thinking of doing. I'll probably put as part of that advanced Terraform and then people can vote for whichever one they want. So this is how we specify our provider configuration in Terraform. So let's go ahead and do that quickly for Azure. So let's take our first steps, Terraform in Azure. So now if I go back to my Linux virtual machine, I've got Terraform running on this machine. What do I do? How do I even begin to use this? First thing that I need to do is I need to define a directory that I'll call my working directory. This is the directory that I'll be working from in my use of Terraform for the infrastructure I want to provision on Azure. So I'll just make a directory. I'll say make directory az-terraform, and I've made that directory, and then I can change directory to that directory, enter, and then let's clear the screen. So now I'm in this directory that I've made. I'll call it my Terraform working directory. If I do a list, it's empty, absolutely nothing in it. What I need to do, the first step I need to do is I need to create a simple .tf file. If you're on Windows, this is the same thing that you would be doing on Windows. Just create a directory, your working directory, call it whatever name, create an empty file, .tf file. In this case, I'll call it vim. I'll say first Azure VM.tf. Essentially what I'm saying, I want to create a new file called first Azure VM.tf, enter. It's an empty file, it's got nothing in it. So the very first thing that I'll configure here is what I mentioned earlier, which is the provider. I'm telling Terraform, here's the provider that I want you to make REST API call to, and here's the authentication to it. And that's very, very straightforward to do. So all we need to do, if I go back to, let's go back to the one I showed to you earlier. Let's go here. Okay, this for example, not this one. So let's go Azure Terraform, and I'll just copy this Terraform provider information. So sorry, did they ask the question? It uses service principal name to connect to Azure. Does it support Outback? Yes, it does. Jide, it does. So it supports Outback, but it's not only limited to that. So actually, I should show you this. If you go to Terraform's website and then go under providers, and then you have all the different providers that are supported. So let's take Azure for example. If I go under Azure and then I go under the Azure providers, it gives me different ways that I can authenticate. So one of the method is service principal. So that's preferred because you can authenticate via the Azure CLI. Yeah, you have to authenticate via the Azure CLI before you can run your template. That may not be suitable if you're using a management server or you're using a provisioning server that you're running your provisioning from. That can be suitable if administrators are just making the calls from their computer, but that won't be suitable for that. So in that situation, service principal is probably best. So they have different authentication methods depending on which scenario that you want. And I recommend having a read through this, but I'll just be going through this one today, service principal. You can use managed service identity if you want to. And in terms of that, it does support roles, because what we're actually going to be doing is, at the moment, I have my Azure account here. I don't have any service principal configured, but I'll show you the easiest way, by the way, to configure a service principal in Azure. It's to use the Azure CLI. I love it very much. It's absolutely straightforward, straight to the point. Its PowerShell is, if you're trying to do this using the Azure portal or using Azure PowerShell, it's really it's messy. This is a one line. This is just a one line. You just go create a new role. Do not create a new role. Create for Howback role contributor. In other words, the role that you're going to be given the service principal is contributor role. So Jide, to answer your question again, you can put in whatever role that you want. In Azure, you can limit this. You can even create your own custom role and specify that role here, and then specify the subscription scope that you want this to be in. So that's all we do, and then we create a service principal. It's going to give us an output like this. We're going to take the outputs that we get. We're going to convert that output to this, our provider configuration. And by the way, this is the same for whatever, for whatever provider that you're using. If you're using AWS, it's essentially the same process. We're talking about Azure today, so I'll skip that. But if you go to AWS, you're configuring your provider. You just need to provide your access key, your security key, and the region that you want. Again, this is just keeping it simple. There are a lot more advanced things that we could do with this. We don't have to specify this in this document. We can specify this, as we mentioned, as variables. We could refer to them. We could make different references outside. We could specify the version of provider to load if we don't want it to load the different provider. But again, that's beyond the scope. But just know that there's much more advanced stuff that we can do with this. Let's just quickly go and configure the one for Azure. So what I'll do is I'm logged into my Azure environment already. I'm logged into the Azure Cloud Shell. Okay, let's log back into the Azure Cloud Shell. Seems as if it's logged me out. Log back into the Azure Cloud Shell. And what I'll do here is I will just provision. I'll go ahead and just provision my service principal with the one-line code. Absolutely lovely one-line code. It's really simple to do. Let's go. Yeah, okay. Now I'm logged into that, and let's go. Okay. Just waiting for this to load. I'll copy and just paste the command. There we go. It's getting there. There we go. Finally, it takes a while. So one of the things that I can do here, and hopefully, all of you are good guys, you're not going to try to hack my Azure account or anything like that. So this, by the way, the reason why I'm showing you Azure Cloud List is to tell you that this supports not just Azure Public Cloud. If you're using one of the Azure special regions like Azure China, Azure Germany, or even Azure Government, you can specify the Azure Cloud that you want it to access. So you can specify that in the provider file. So in this case, if I just do an Azure account list to get my subscription, because I need my subscription ID. So if I get, that's my tenant ID. What I need is my subscription ID. I need this ID because I'll use it going forward. So I'll just pop that in a text file somewhere here for me. And what I'll do here is let's copy the command to create a service principal. There we go. If I go here, so what I'm saying here is create Azure AD service principal, create for role-based access control. So this switch is very important. And I'm specifying the name. I'll call it AZ Terraform. And the role I want is contributor, and then I specify the scope that I want the permission to be. So if I want to give it permission to across all subscription, I can add that here. If I want it just to one subscription, I can put that in there, which is what I want in this case. So I'll just put that to my subscription. And if I go ahead and run this, it's going to create an Azure Service Principal for me called AZ Terraform, and it's going to give me the output. So this may take a while, but you're going to see it's going to start the role assignment. And if I show you what it's actually doing, if I go to Azure Active Directory, and under Azure Active Directory, if I go under Application Registrations there, now if you go here, so this one used to confuse me, because you come under Application Registration and then it's empty. All you need to do is change that from My Apps to All Apps, right? And then it's going to show you. So that's my that's my new application registration of AZ Terraform that is creating there. And then it's going to assign it a role. If I go under my subscription, it's going to assign a role to it. It's going to assign a contributor role. So if I go under my subscription and I go on the Azure Hangout, so if it's done it, yeah, and there you go, you can see AZ Terraform as that role associated with my subscription. So that's what it's done, and it's done it just with a single line. Let's go back to Azure Cloud Shell, and I'll get the output from there. Yeah, it's done. So now that I have this output, what I'll do is I'll copy this output and I'll put it in a notepad somewhere, show you what I'm about to do with this. So let's go edit font. Let's make it larger. Let's make it like 20 and paste the output there. And then what I'll do is I have my subscription ID here. I'll also copy that. And hopefully, you guys are not going to try to hack me now. or anything. And I'll just go ahead and paste and get the provider syntax of Terraform. So straightforward stuff, Azure provider syntax. This one, I'll go ahead and copy this. and I'll paste this here, and I'll just match the outputs to this. So subscription ID is my subscription ID. My client ID is the application ID. My client secret is the password here. And my tenant ID is my Azure AD ID. And once I have this, I can copy this, go back to my Linux machine where I have the new file that I just created, press I to insert, or paste that in there. And there you go. I've just configured my provider. And I can do the same for any other provider that I want that Terraform support. I can do that. And once I have that, I can do escape, write, and save it. And that's done. If I do cat, I have that in that file. So that's the first one. So I've configured my provider. That's the very first thing that you need to do. So let's check out the rest of the things that we need to do, and then we'll conclude with the last demo of the day, which will be provision our infrastructure. So once we've configured our provider, now we have to start defining the resources that we want to deploy. Each provider specifies different resources. And again, this is where I'll point you to the Terraform documentation. So if I go under the Azure RM provider, and if you go here, you can see the resources that we can have here. So Azure RM App Service. Essentially, it's very robust. So compute resources, CDN resources, and if you click on any of them, like Azure RM Virtual Machine, it's going to tell you exactly how to define it. Essentially, don't be afraid of this. If you're familiar with Azure Ham template, this will be easy to you. Essentially, what you're defining is you're defining your resources and your parameters, similar to what you do in an Azure Ham template. The only difference is this can support commenting, which is absolutely lovely because they can add an ampersand, sorry, not ampersand, I can add the hash sign and then put a comment and say, this section I'm creating a virtual network, this section I'm doing this. So that's the main thing. So that's the resource that we need to start specifying. AWS supports its own resource. The format of the resource is very simple. Provider name underscore resource type. For example, Azure Resource Group is Azure RM, which is the provider name, resource group. Virtual network is Azure RM underscore virtual network, and then the name of the resource that you're provisioning. So it goes in depth, and then you can go, and then you can do some really interesting things. Like you can see over here, we are specifying the resource group name, but we're not specifying it directly. We're just going the resource provider name dot whatever name that we give the resource group dot whatever name. So we can start calling this. Essentially, if you're familiar with the Azure template, this will be straightforward to you. So let's move on quickly. So once we configured our resources, which we'll do now, first thing that we need to do is to run Terraform init. This is very important. This is the first command that you should run after writing a new Terraform configuration. This is because it's going to do a bunch of things in the backend. One of the things that it's going to do in the backend is going to download the required providers and the required provider plugin to run your configuration. So in the backend, if you specify the provider for Azure RM and AWS and Google Cloud, it's going to download the required plugin to actually implement that in the backend for you. It's safe to run it multiple times. If you run it multiple times, it's not going to accidentally wipe out your configuration. It's never going to wipe out configuration or wipe out state. So just to know that. So once we run Terraform init to initialize, then we run Terraform plan. Terraform plan is essentially to say to Terraform, have a look at the current state of my infrastructure, which we don't have time to cover states today, but it's going to say, have a look at the current state of my infrastructure and have a look at the codes that I've just given to you and let me know what is going to change. So this is very important. So if you're familiar with Unix and Linux, this is similar to like the diff command, the diff command. So where it can tell you the difference between this is what the current state is, this is what you've told me to apply, here are the changes that I will make based on that. So we'll run it and you see what that looks like. And then once you've run that, then you run apply. Apply is to say, go ahead and apply this infrastructure. And you don't have to worry about dependencies. Remember that we need to worry about dependencies when doing like Azure Ham template and stuff. Terraform will handle dependencies for us. We can draw the dependency graph afterwards if you want to, but it's going to handle the dependencies for us. It's really robust. So that's why many people love using this. Standardizing on this is because do we start learning just ARM template when we're going to be using both ARM and AWS? Well, we want to be able to just use a single tool across whatever platform that we're using. So let's go ahead and do the last demo, which is the last thing that we're talking on today. And what I'll do is I'll go back to my configuration file and I'll make some modifications here. So if you want to follow along, I'll put this link in the description below. This is directly from Microsoft website. Create a Linux VM using Terraform, and it's going to give us, it actually gives us, it breaks it down and tells you what the syntax are for the different things, and then at the end it gives us a complete script. So here's the script that we need to paste. So you can see it includes the provider configuration. So what I'll do is I'll copy this for the complete script, and I will get Visual Studio Code, which I think I have running already actually. Well, yeah, I'll get Visual Studio Code and I'll get a new file, and I'll paste this in the new file. And I need to zoom this. Where's my zoom button? There we go. Oh, it's view, control plus minus, control plus equals to. So control plus, oh, there we go. That will do. Probably did it too much. That will do. So what I just need to do is I just need to modify two things that I need to modify from this template that I got from Microsoft. So I'll need to modify the provider configuration to match my current provider configuration that I have on my Linux machine, which is this one. So I'll copy this and I'll go over here and I'll paste this here. So I have my provider configuration there, and I'll just copy everything. Actually, before I do that, I said there are two things I need to modify. So my provider configuration, the other part that I need to modify is because this is deploying a Linux VM, it needs a public key. Here we go. So the key data. So I need to put in a valid public key here. So you can change that to password if you want to, but in my own case, I'll just use my public key that I have here, and I'll just go ahead and paste my public key there. So now I have my public key in here. I won't be making any more changes. I'll just go ahead and copy that and then go back to my Linux machine. I'll delete all this existing configuration. There's a simplified command to delete this, by the way. I think it's and I'll just go ahead and paste my templates there. So if I scroll all the way back up, I should ensure that my provider is there. So essentially what we're doing here is we're defining, I know that this may not be too clear for many of you, so let me show you from Visual Studio Code. So we're defining a variable within the file, which you don't have to define within the file, you can define outside the file, but again, that's something that we can cover. We can cover everything, so we can cover that one now. This is just to introduce us to this. So we define a variable called variable resource name so that we can call this, that's the default, but we can call this so that if I want to change my resource group, let's say I want to deploy the same infrastructure into a different resource group, I just need to modify the resource group name, and it's going to modify everything. So I can deploy variables and functions and other things. And then we're saying the provider configuration, which we can do for any provider that Terraform supports, and then the resources. We start with creating the resource group if it does not exist, then creating the virtual network. So let's just go ahead and deploy this so that you will see how that works. So now that I have this all done, I go ahead and press save my file. Yep, and then if I do a cat to read and ensure that everything is in there. Yep, so everything looks good. So from within my working directory, I need to run the first command that we mentioned, which is Terraform. I'll answer your question in a minute, Bharat. Terraform init. And you see what it's going to do. You can see it's initializing provider plugin. It began to download the provider plugin that I know. Yeah, so it's going to begin to download that. And you can see it's like this is the version that it's downloading, version 1.4 of that provider plugin. And it says you may now begin to work with Terraform. Okay, let's go Terraform plan. And then it's going to begin to run through the state. So we won't talk about states today, but Terraform keeps a record of the state of the file, of the infrastructure. So it's not a good thing once you start using Terraform to go outside of Terraform to deploy your infrastructure, because Terraform needs to know the states. There are other advanced topics that we can talk about, like remote state and integration with source control, but again, that's beyond the scope of this one. So wherever you see plus, that is the resource that Terraform is going to create by making API calls. If it has minus, that means the resource that will go. If it has the curly sign, that's the resource that will be modified. So just be aware of those. And then you can see down here, it says I'm going to add 9 new resources. I'm not going to change any. I'm not going to destroy any. So once I have my plan and I'm okay with the changes that will be made and things that will be added, I just go ahead and run Terraform apply, enter. And instantly Terraform will take the file, ask me to specify Terraform will apply perform the actions described above. Enter yes if you want to continue. I'll say yes. Then it's going to start provisioning my infrastructure. And while it's provisioning that, I can go to my Azure portal and have a look at that. So if I go to resource groups, I can see my resource group is now there. It's already created it. It's going to begin to deploy my resources under that resource group. You can see it's created the network security group, the public IP, and it will carry on. And from then on, if I need to make some changes, let's say I need to modify the VM size, I don't go to the portal and click next, next, next. I just go to my Terraform configuration file or template, make the modification there, check the plan, make sure I'm satisfied with what's going to modify, and go ahead and apply it. And if I want to destroy it, it's the same thing that I need to do. I just need to go ahead and type Terraform destroy, and it's going to destroy everything that's already created. Or if I want to remove one resource, I can go to my template, remove the resource, Terraform apply is going to calculate and go this resource, you've modified it or removed it, I'm going to remove it now. So that's the way that works. So that's essentially the end of our webinar today. It's question time. If you have any questions, you can unmute yourself. Hello. Oh, sorry. Carry on. Sorry. Yes. 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 So Terraform will calculate the dependency for us. So for example, if you look at, yes, if you look at this template that we just deployed now for this one, you notice that if we go before, if we wanted to create, let's see, a network interface card, right? Let's go network interface card. Um, before we have to go, depends on, before you create network interface card, we have to tell Azure Ham template, make sure that the subnet exists first, right? But you notice that we don't have to do that here. Terraform just calculates and goes, I know that this depends on this one because you're referencing this one in here. So it's going to calculate all those dependencies for us. Yeah, 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 yeah. hmm you mean if you add, yeah, if you all you're doing is you're just adding VMs to an existing availability set, yeah, it's just going to add them. It's not going to delete them. Yeah, it's not going to. Yeah, so that's what in that scenario, in that particular scenario, that's what it's going to be in the scenario that you described. Yeah, yeah, yeah. And then the other thing that you need that you can do with Terraform, which is again, remember the Terraform plan command, right? That's awesome. Any change that you make to your code, if you run Terraform plan, it's going to tell you what's going to change. No, before you run apply, always run plan. Yeah, so plan will tell you what's going to change. So if you look at what's going to change and you notice it's trying to destroy what it should not be destroying, you understand. So it's that robust because it's going to tell you this is the changes that is going to happen as a result of the code that you've changed. Yeah, 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 yeah. In in Terraform, that is called modules. So which again I will put out. So if you monitor my LinkedIn, I'll put out some of the other webinars that I'll do. If you're interested in that, just vote for it. So in Terraform, if you go to Terraform modules, so that's a much more advanced topic in terms of where you can create reusable templates that you can use. Yeah, but you support it. So in Terraform, that's called modules. Yeah, and problems. Yeah, yes, they are called modules. No, no, not necessarily. So you can refer to them. So for example, there's a Terraform registry that contains a bunch of modules that people have created. You can have your own separate registry and you can call the modules from different sources if you want to. So you can see there's some modules that are popular, there's some modules that are created by the providers themselves. So you can specify and say, I'm calling this module from this particular source. And Terraform will refer to it based on wherever you specify. From whatever source. Exactly. Yeah. Any other questions? Yeah. So yeah, so just watch out. So I'll post the next topics in my head, and then if that's what people are interested in, I'll be happy to do that. So I do this every week. So it depends. So for example, if I put it out and people say they want to learn about Chef, then they want to learn about Terraform, then we'll have to do Chef. So so you understand. So if you can get enough people to vote for what you want, that's fine. Yeah, no problem. Any other questions from anybody? Okay. Yeah. So Docker falls under. So you're talking about Docker. So oh no, Terraform does support Docker. There's a provider for Docker. So if you go on the Terraform provider, yeah. So if you go on the Terraform providers, if you go on that, there is Docker here. So it can interact with Docker containers and Docker images. So it does. So you can see here, this is how you configure the provider for Docker, and then you can configure the resources that you want. So there's not a lot of resources. It's container, image, network, or volume. But yes, you can use Terraform to provision those. But if you're thinking about something like templating, server templating, you'll be using something like Dockerfile to do that, or something much more advanced. Exactly. Oh yeah. Not compose files directly. Um, yeah, no problems. Yeah. Any other question? Oh yeah. So recording will be available, Barat. So after this, I'm gonna do some editing of the recording, and then I'll probably. So between today and tomorrow, the recording will be on YouTube, and I'll put that on my LinkedIn, and I'll put it on my Twitter, and it will also be on my YouTube channel, and it also in the community that we have. So the community that we have is called um, MCSC study group. I'll post the recording here also. So just look out for that. So no, that will be between today and tomorrow. Yeah, yeah. I think if I have enough time to do the editing today, I'll post it today. That's my plan. Yeah, no problem. Thanks, Kofi. Good to see you. Okay, no problems. Yeah, I hope that the session has been very useful for you. Again, I'll put out other sessions that I'm planning to host. Nice. Nice to hear that. Okay, so thanks very much for joining today's session, and I'll see you in the next one. Have a wonderful day, afternoon, evening. Bye for now.